So for number 9, we have a man and he's walking away from a light. So here's our light. Let's make our nice yellow light. Okay, and the man is walking away, and let's put the man right here. And he's making a shadow in front of himself with the light behind him. So that's our kind of our picture. Now how we solve this is to make this a right triangle. And then we make this another right triangle. And we're going to use similar triangles. Now we know from the problem it said that the height of the lamppost was 4.5 meters and he was 1.6 meters tall. And let's call the distance that he's moving away, this distance, x, and this distance, the distance how long his shadow is, s. And the question says at what rate is the length of his shadow increasing? But first it said he's moving away from it with at a rate of 1.2 meters per second. So that means we're given dx dt is equal to 1.2 meters per second. And it wants to know what is the rate the length of his shadow is increasing. So this is half, and we want, that would be, because we made it s, ds dt. When, this is the when, and then x, how far he is from the light is, let's say, 6 meters. X equals 6. With the picture, we can set up similar triangles. So we would take 4.5, which is the height of the lamp, is to the length of this triangle. So let's do it by color. The green triangle is your first similar triangle. So that's 4.5 for this side, and x over x plus x for the bottom. And that would be similar to using a different color. Let's use red. This triangle, which is 1.6 high, to S. All right, so we can set this ratio up, and then we'll simplify it by cross products. So 4.5S equals 1.6 times x plus 5, and multiplying 1.6 through, I get 1.6s that I have to subtract from 4.5. So I'm left with this equation, 2.9s equals 1.6x. So then that's the equation that I take the implicit differentiation. I say 2.9 ds dt is 1.6 dx dt. And so ds dt is 1.6 times dx dt, which is up here, dx dt. And then I divide that by 2.9. And I get ds dt is equal to 0.66, everything's in decimals, so 0.662, and that's what the answer was on your sheet. So that was number 9. We'll move on to number 10. Okay, number 11, not number 10. Number 11 is about a spherical snowball. So there's my pretty bad spherical snowball. It says the volume is decreasing at a rate of 1 centimeter cube per second. Okay, so I guess it's melting. So we would say dv dt equals negative 1 centimeter cubed per minute. Is it minute or second? I guess it's minute. Okay. Slowly melting. Okay. So then we have, let's see. It says, what rate is the diameter decreasing? Okay, so diameter. So we want, I guess, capital D dt for the diameter when diameter equals 10 centimeters. Okay, so we know we need to have our dV, our volume of a sphere in terms of diameter, right? So let's start working on that. The volume of a sphere is 4/3 pi r cubed. Now r is equal to 1/2 the diameter. So the diameter over 2. So we can rewrite that r with the diameter in it. V equals 4/3 pi and d over 2 cubed. Or V equals 4/3 pi d cubed over 8. So hey, let's simplify this. That would be 1 and 2. So I think I get nothing on the top except pi d cubed over 6. So let's go with that and see how that works. If not, we'll go back and redo it. So when I take dv dt equals 3 pi d squared d capital D, this was supposed to be a capital D, dd dt over 6, right? So yeah, it's pi over 6, so 3 pi over 6. Okay, so let's clean this up so it looks like I know what I'm doing. That would just go to 2. So then we have dv dt, it's -1 equals pi, and we have diameter now at this time, so that's 100 dd dt over 2. So dd dt is equal to -2 over 100 times pi, or -1 over 50 pi. And the units would be centimeters per minute. Now, depends on how you want to say this. The diameter is decreasing at 1 over 50 pi. If you say it's decreasing at a rate of 1 over 50 pi centimeters per minute, or you just say at a rate, is changing at a rate. Okay, so that's how you would say it. Either use the negative when you say changing, or if you say decreasing, you don't need the negative. All right, so that was 9 and 11.